Today we're going to convert some exponents to logarithms, and I want to give you some context as to where this concept is coming from. So if you recall, we've been doing some percent change and problems, which means we were finding the new balance after the principal and it was 1 plus or minus the rate divided by the number of times we compound it raised to the nt. So this is what we've been using for quite a while, or not quite a while, but a few days. So if you are being asked to find the rate or the n, something that's the time or the n, if you're being asked to find the exponent, you might have had some troubles on your Delta Math assignment. Because in order to solve an equation, you have to work backwards. But we haven't talked about what's the opposite of an exponential function. And that's what we're going to talk about today. So what you need to understand is that logarithms are opposite operation. Of exponents. Really what they are is another way of writing exponents. Let me say this again. Logarithms are another way of writing an exponent. So, as a reminder, if we have 3 to the 4th is equal to 81. 3 is the base. 4 is the exponent. 81 is going to be the answer. Everyone agree with that? I certainly hope so. 3 is the base, 4 is the exponent, 81 is the answer. I'm going to rewrite this relationship as a logarithm. What does that mean? Well, I'm just going to put numbers in different spots. So we can say the log of the base of the answer is equal to the exponent. And the way I would say this, it would be the log base whatever of the answer is equal to the exponent. The log base of the answer is equal to the exponent. So let's see a couple of these in action. Because really all you do then is plug it in. We're going to turn this, so here the base is 3. So this is going to be the log base 3. Then you put the answer of 81 is equal to the exponent, which would be 4. So let's look a couple of these. All right, so again, it is going to be the log base answer is equal to the exponent. So log The base here is 12 of base 12 of 144 is equal to the answer, which is 2. Log base 8 of 64 is equal to 2. Log base 3 of 1 is equal to 0. Log base 15 of 225 is equal to 2. And log base 5 of 125 is equal to 3. So you can see all we're doing is identifying, we're rewriting these exponents in logarithmic form. So we look for the base first, and it drops down low. It is called subscript. Then we put the answer. And then we put the exponent is afterwards. So then the exponent is at the end. 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 You are going to do the even ones. So what if I'm asking you to do it in the other way? Well, obviously, it is the log base answer equals exponent. So the base here is 3 to the what exponent? Well, exponent is at the equal sign, which is 4, is going to be equal to 81. This is our base, so 15. This is our exponent squared is equal to 225. (11) to the negative 2 is equal to 1 over 121. Now that makes sense, because remember, when we have a negative exponent, we always remember to do 1 over. So 19 squared is equal to 361. And I'm not doing any math. I'm simply translating it. I'm rewriting my log as an exponential form. So I'm going to rewrite my log. It is base 3 risen to the negative 5, and it's equal to 1 over 243. And the last one, 13, this is my exponent, is equal to my answer. You do the other 4. Now, when I ask you to evaluate them, this is where you actually are going to be doing some math. So I'm going to do 4 to what exponent is equal to 64? Well, I'm going to make both of my bases the same. This is going to be 4 to the x, and I know that 64 is going to be 4 times, or 4 to the third power. Because if I break it down into 4s, 4 goes into 64 16 times, and then I can break 16 into 4 times 4. So there are 1, 2, 3 4s. Now I can tell, because my exponents are now equal, because my bases are the same, x is equal to 3. So 6 to the x is going to be 1 over 36. So the first thing I need to recognize is that this is going to be 1 over something. So I know that my x is going to be negative. So let's deal with that first. So I'm going to make my x negative. That means I put 1 over 6 to the negative x is equal to 1 over 36. Now my bases are the same. I have 6. Well, how do I turn 6 into 36? Well, 6 is the same thing as, 36 is the same thing as 6 squared. So I can simply do 1 over 6 to the negative x is equal to 1 over 6 squared. And so if negative x is equal to 2, then x is going to be equal to negative 2. Next one. So 4 to what power is going to be equal to 1? Now this is just a rule that you should always remember. Every number to the 0 power is 1. So x is going to be equal to 0. Six to the x is equal to 36. Well, that means it is 6 is equal to 6 squared. And I see here x is equal to 2. Two to the x is equal to 4. 2 to the x is equal to 2 squared. X is equal to 2. So I want you to do each of these. Remember, because this one is a fraction, number 30 is a fraction, and because number 28 is a fraction, your answers are probably going to be negative. Hint, 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 hint. Now I would use my orange paper if I don't know my powers, or you may need to use a factor tree if you're unfamiliar with how to break them down, but they are fairly standard numbers. So you need to finish this. There will be no need to turn it in because we're doing it in class. And I will, please reach out if you have any questions. Make sure you've done both of the Delta Math assignments. Now that you've used this, you should be able to solve for a logarithm in Delta Math.